Another Institute Physics Friday for you. I'm in my classroom, got my physics up on the board, but I've got a little bit different thing going on. So I have a bungee cord here, and I have a bicycle wheel hanging from this bungee cord. So this is just a regular bicycle wheel. It spins, nothing too fancy. This is what we've got here. But if I were to hold it up horizontally like this and let go of it, what would you expect to happen? Would you expect it to just fall down like that? I would expect it to just fall down like that. There's nothing holding it up. But there's a cool little physics magic trick you can do with this one. If you take your bicycle wheel, and I'm going to hold it sideways like this, and I'm going to grab a part of it, and I'm going to start it spinning. So I'm going to get this thing spinning, spinning. Trying to get it spinning as fast as I can. Now what I'm going to do is I'm going to hold it sideways like this, and I'm going to let go of it. What do you notice? You notice that this bicycle wheel is actually staying up. This part is not falling down. Why isn't it falling down? It should be falling down. Gravity's pulling on this side. Why doesn't it actually fall down? And the reason why it doesn't fall down is physics. We have some rotational motion going on with this thing, and that's what's holding this thing up. So I want to talk about that a little bit. I'm going to take this bicycle wheel off this bungee cord for a second and talk about what's going on. So as this bicycle wheel is spinning, it's going around and around. If I take my fingers and I curl it around in this direction, it says that the angular momentum is pointed towards you. So when I have it sitting here and I let it fall on that side, one of the things that happens is that side means it's going to change its angular momentum. If angular momentum changes, in other words, it falls down because the angular momentum was pointed towards you, but now it's falling down, it's going to feel a torque, and that torque is always perpendicular to the angular momentum. So it's going to cause a torque to push it in this direction. And so it starts to twist in this direction, but then it falls down. So it causes a twist in this direction. It starts to fall down, causes a twist in that direction. So it causes an extra twist of this bicycle wheel around in a circle. So when it's like this, it falls down like normal, but once you get it spinning, it'll actually stay upward. You can actually hang on to just one side of it and it'll stay up. It doesn't actually fall down. So as you change angular momentum, you have to have a net torque to actually do that. And that net torque is going to act perpendicular to it because of the right-hand rule. Hope you enjoyed this Physics Friday here at the Institute.